x86 and PCs have walked side by side since IBM launched the IBM PC in 1981. Over the years, several companies licensed Intel's instruction set like AMD, Cyrix, and VIA, but of those, only Intel and AMD still actively make x86-based processors today. Mobile phones, on the other hand, run the ARM instruction set. Announced only 4 years ago, RISC-V threatens to displace not only x86 out of high-end PCs and servers, but also ARM out of the mobile and IoT market. Could our beloved gaming PCs be running RISC-V processors someday? Perhaps, or perhaps more likely, RISC-V might make dedicated gaming PCs and the concept of the desktop PC as we know it a thing of the past. The first thing we should address is what exactly is RISC-V? Well, an ISA or instruction set architecture is the interface between software and hardware, and RISC-V is an open standard of an instruction set, so it's not really open source but rather open spec. In other words, while ARM or x86 require a license to be used and can't be modified by licensees, RISC-V can be implemented by anyone for free, and companies can modify it to fit their needs, at least to some extent. So when a company like Qualcomm gets an ARM architecture license for their mobile SoCs, they can't extend it with their own instructions, but with RISC-V they can. Now, what sort of crazy person would want to extend an ISA anyway, you might ask? Well, I know this is a far-fetched scenario, but as a simple example, let's say a security flaw is discovered in some chips that you use, or maybe several security flaws. If you were able to add features to the ISA, you could mitigate these security holes yourself and potentially save your business until a hardware solution was implemented. When you look at how many companies are adopting RISC-V, companies like Nvidia, Alibaba, Qualcomm, Google, Huawei, and many others, you might think that RISC-V must be, say, 50% faster than x86, or maybe it's 50% more efficient than ARM cores. The reason why RISC-V is gaining so much momentum has nothing to do with benchmarks or performance metrics, although it's certainly possible to achieve those results if that's what a solution requires. The real reason RISC-V is gaining so much traction with so many large hardware companies has to do with the business model. Before, companies had to choose an ISA like x86 to build their products, which would lock them in and made them depend on Intel or AMD to innovate and advance their proprietary chips. Now, with RISC-V, companies can choose where the IP cores come from. They can choose open source cores, or they can choose commercial ones, and more importantly, they can extend these cores to fit their needs. So a company doesn't have to wait for Intel to mitigate Spectre and Meltdown, or whatever next week's security flaw will be with the next wave of chips. Google doesn't have to wait for AMD to provide full support for AVX 512 in EPYC 3. With RISC-V, companies can customize the cores in this ever-evolving industry. As you can imagine, this is a huge competitive advantage in an industry that feeds on innovation. So you know how USB became a standard and every computer has USB ports to connect devices? You know how Ethernet became a standard, and when you want to set up a network or connect your modem, you use an Ethernet connection? This is what RISC-V is for instruction sets. RISC-V will become the standard ISA for all computing devices, including our gaming PCs. So a good analogy, I guess, would be that x86 is like an Apple proprietary connector that locks you into the Apple ecosystem and forces you to carry around all manner of adapters, while RISC-V is trying to be USB Type-C, an open standard. So now that we know what RISC-V is, you might be thinking, I haven't heard anything about this. If RISC-V were really that disruptive, surely we would be hearing more about it, right? Where are these RISC-V products? Well, for perspective, in 2019, shipments of RISC-V SoCs are expected to be in the millions. Remember, RISC-V was announced to the public only 4 years ago, and we're already at millions of SoCs. They might not be making the headlines like Ryzen 3000, but the uptake from the industry has been tremendous. While most of the RISC-V implementations so far have been in embedded and IoT devices, next year the RISC-V Foundation expects to be a big push in high-end implementations in 3 key areas: servers, auto and mobile, and the desktop might be coming next. An interesting aspect of RISC-V is that it's designed to be scalable, so it can be implemented in something as complex and large-scale as a supercomputer, down to something as simple as a small core inside of a mainstream processor. That means that a company like AMD, which uses the x86 instruction set in their CPUs, can actually benefit from RISC-V in the short term by using it for something like the management engine inside of their chip, or perhaps the audio IP. In Ryzen 3000, for instance, all of those IPs have their own proprietary instruction sets. If you bought a Ryzen 3600, for instance, there are 15 different ISAs inside it to manage all of those IPs. So going forward, using open standards instead like RISC-V would make it much easier for AMD to manage everything that's going on inside their chips. Nvidia is already using RISC-V in-house, and they have confirmed that they are building some of their next generation products with custom RISC-V cores. The MCM GPU that I talked about a couple of videos ago is just an early example of the shift that Nvidia is making towards RISC-V. Their next-gen SoCs will ditch ARM in favor of RISC-V, and their GPUs could follow shortly after. So we're going to see more and more smaller parts of chips using RISC-V until eventually in a few years, both general purpose cores and things like graphics will most likely migrate from proprietary ISAs like x86 or ARM to RISC-V. It might sound optimistic, but the movement in the industry clearly points towards this shift. There has never been an uptake to a brand new ISA happening so quickly and so dramatically in the hardware industry. Now, whenever there's talk of a paradigm shift of this magnitude, there's always resistance, and not just from incumbents, but probably from you too, listening to this. I mean, we just got Ryzen 3000, and I've talked in past videos of lots of exciting things on the horizon for x86, so why stir the waters? Can't we just be happy with x86 and the status quo? Well, think about it this way. Look at how Linux, an open source platform, potentiated the growth of the internet. The digital age would probably not have come about as we know it today without a paradigm shift in terms of the software stack and the standardized infrastructure required to connect us all and evolve as our needs change over the years. Without open standards, we probably wouldn't have Twitter or Instagram or even a platform like YouTube for free. So instead of feeling this inertia against RISC-V, think about the possibilities. The same revolution that happened in software with Linux and all the great things that came from that could happen in the hardware industry because of RISC-V, and to me at least, that's very exciting. Who knows what awesome hardware could emerge from this shift? RISC-V could create a world where we don't have to depend on 2 or 3 companies to release new and more powerful, innovative products to address our needs every couple of years, but have perhaps dozens or even hundreds of companies making CPUs and GPUs. As a consumer, what's there not to like about that prospect? So let's take a quick look at how exactly RISC-V will affect the market in the coming years. Starting with servers, the biggest challenge going forward has to do with adaptability. The industry is moving towards domain-specific hardware, in other words, specialized hardware to accelerate certain workloads. Intel has identified this trend and have completely changed their business in the last 5 years to try and adapt to this changing market. When you look at their roadmap, it includes FPGAs and GPUs, so what they're calling XPUs. They are trying trying to become an accelerator company. There is a problem with this strategy, however. Some of the players that are entrenched out there have to serve a large market, and when you are serving a large market, you can't optimize for particular segments. Atik Bajwa was talking here about Ampere's value proposition in the edge market. Ampere is working on ARM-based chips for servers, and their plan is to offer optimized products for particular needs. So basically the same as Intel, but at a smaller scale and with more customization. The problem with Ampere, Intel, or even AMD's strategies for domain-specific is that the ecosystem is constantly evolving, and by that I mean almost every month. This is one of the reasons why FPGAs have been so popular with machine learning. They can be reprogrammed to fit needs. So even if these incumbents take suggestions from customers and create optimized domain-specific hardware, by the time it's ready to come to market, the same customer's needs might have already changed. With the exception of FPGAs, which are usually very expensive, it's going to make no financial sense to continue mass-producing general-purpose hardware that can't be customized by customers themselves due to proprietary ISAs. What RISC-V offers in the server space is the ability for customers to customize hardware from FPGAs to ASICs and general-purpose chips, and to do rapid prototyping in a rapidly evolving industry, and without requiring massive production scales. Just like in many server segments, customers want to be able to customize the software to their particular needs. They also don't want to be dependent on Intel or AMD or ARM to implement their suggestions every couple of years. They need to be able to respond immediately to market changes if they want to stay competitive. RISC-V makes that possible. Next, looking at mobile, ARM should really be shaking in their boots. I've shown this concept of disruptive curves in the past, so this is the curve for ARM, which saw slow progress in the early 2000s, then brought massive disruption to the mobile market with the introduction of ARM v8, and is now reaching the plateau stage. RISC-V's curve starts here, and its momentum is just astounding. One of the biggest proponents of RISC-V, unintentionally, is none other than Donald Trump. Just 2 months ago, the Chinese giant Alibaba announced the RISC-V open-source processor, the Shuang T910, which is tailored for 5G, artificial intelligence, and Internet of Things. Because RISC-V is extendable, Alibaba was able to extend the instruction set with more than 50 instructions and optimize the existing ones by 40%. They would never have been able to do this with proprietary IP. This 16-core processor that runs at 2.5 GHz is a direct response to the US sanctions on Huawei, which led ARM to suspend Huawei's license. Chinese companies are waking up to their dependency on Western-developed hardware and are desperately looking at alternatives. RISC-V is exactly what the doctor ordered. ARM, who have historically done business by licensing their proprietary ISA, responded just a few weeks ago by introducing their ARM Flexible Access, which provides access to ARM's technology portfolio at a reduced fee and with no obligation to purchase a full license. This is what fear looks like in this industry. If ARM are feeling the pressure already to the point of changing their business model, imagine what will happen when mobile phones start shipping with RISC-V IP cores instead of ARM ones. If you look closely at the RISC-V Foundation partners, you see Huawei, ZTE, Samsung, Alibaba, and Xiaomi. Why do you think these huge mobile phone manufacturers are so interested in RISC-V? Out of nowhere, RISC-V has put an expiration date on ARM. And finally, let's look at the segment that probably affects us PC enthusiasts the most: Edge. So the current hardware economics are based around building just a few different general-purpose chips, but each at high volume. To make this model work, what Intel and AMD need to do is sell a ton of Ryzen and Core chips to cover the investment, and hopefully turn a profit. But this model is at odds with what the industry wants, which is a multitude of custom chips in low, medium, and high volume production. Until now, tech companies had no choice but to buy from Intel and AMD when it comes to general purpose chips, but if they could, they'd choose a different model. So costs are ultimately the main obstacle for creating custom semiconductor-based products. If you have a killer idea for a software app, say like the next WhatsApp, you don't need to develop a database system or build up a complete software stack. Everything you need already exists, and it's open source. With services like Amazon's AWS, you don't even need to build an infrastructure. All you need to do is code the app, or hire a few engineers to do so. Why can't it be the same with hardware? If you have a killer idea for a hardware product today, let's say a console, right now you have no choice but to go to someone like Intel, Nvidia, or more likely AMD, and ask them to create a custom chip for you. And you need to build it at massive scale. You can't just build a niche, powerful console that will sell a few 100,000 units. To turn a profit, you need to sell millions of them. RISC-V has the potential to completely change this. A company like Sci5 lets you put together your own chip and go to production at low volume with much lower costs. But what does this have to do with gaming PCs and the desktop? Surely PCs will continue to use x86 for decades to come, right? Well, if the desktop paradigm stays the same, then yes. But what if something else replaced the desktop entirely? I've talked about this in the past, the idea of the edge cloud desktop. So with this shift of RISC-V allowing for custom chips at low volume, the idea here is that for desktop use, all a company needs to provide is a thin client with decent specs. So let's say a 4-core hyper-threaded CPU and a GPU on the level of an RX 570 or GTX 1060, and this could be built on TSMC's cheap 28nm, and then most of your computing needs that require more processing power would be done on an edge server close to where you live. A key difference here compared to our current desktops is that this thin device would be completely integrated, in other words an APU-like chip made with open source IP blocks based on the RISC-V ISA. Alternatively, it wouldn't even need to be a dedicated device. It could just be a 5G smartphone or similar device that you could place on top of a docking platform when you got home from work or school. That docking platform would keep the device charged and connected to a large display and a keyboard and a mouse. Most of what you'd need to do would be done remotely in the cloud, so things like your storage would be in the cloud. If you wanted to run Borderlands 3, you'd just launch the game and the heavy processing would be done on the cloud, while your local machine, in this example your smartphone acting as a thin client, would do some light local processing work. The edge server that you're connected to could be running a container with a Windows instance to run Borderlands in this case, and it could use a powerful GPU like a 2080 Ti to run it at 4K. But then if you decided to play, say, Dicey Dungeons, then it could open up another container with different hardware, like a dual core and an RX 460 equivalent. And then let's say you want to run an app that's not even available on Windows, like say Logic Pro. Another container with macOS could launch on this edge server and you'd be able to run that app from the very same smartphone/thin client as if it were running locally. And when you're done, undock the device and take it with you. So you can see how the concept of a gaming PC or a desktop PC could be on the verge of being completely transformed. If, of course, the remote experience feels exactly the same as the current local Windows experience does. So sure, these thin devices, be them dedicated boxes or just dockable phones, could be based on RISC-V, and that would be incredibly disruptive. But what about those edge servers that would run games and apps remotely? They would still need to be running AMD processors or Intel chips, right? Not really. You see, the openness of an ecosystem is even more important at the server OEM level. Let me give you a quick example. If you look at the Xeon Platinum 9200, for instance, it's a system where Intel offers the complete racks for OEMs. So that's the chip, obviously, but also the PCB, the co-processing units. Everything is put together by Intel. The only thing OEMs like Dell, HP, or Lenovo can customize is the cooling solution. Intel has made it so they can't change anything else. As a consequence, guess how many OEMs are currently offering systems with the Xeon 9200 for mainstream servers? 0. No one likes a walled garden. Think about it. How can Supermicro differentiate their products from Lenovo if they are selling the exact same thing? At the OEM level, being able to customize a solution is paramount. So at the edge, OEM providers like Lenovo could build a RISC-V based system with their own custom extensions that provide some sort of competitive advantage. Like maybe Lenovo adds a video encoder to their edge servers that makes cloud gaming look identical to running it locally, and then maybe HPE offers a solution that has 0 lag, so they don't have to depend on Intel or AMD to come up with these solutions. They can make them themselves for this particular use case. So you can see how disruptive RISC-V would be even at this level where Intel and AMD are entrenched. This whole scenario might sound far-fetched, but it's where I can see an opportunity for RISC-V based devices to disrupt the desktop market, and not just servers and IoT, just a cheap small box that you connect to a monitor, or even a new type of smartphone that lets you do everything that you already do now but runs it remotely. How would all this work as a business model? Well, look at how other industries have changed in the last few years. A desktop provider, let's call it, could charge you a monthly fee for all the extra performance that you might need, sort of like a tiered Netflix subscription. So that would include extra CPU processing power for when you need to render a video, or extra GPU processing power for when you want to play a demanding AAA game at 4K. Perhaps different tiers can even offer different operating system support. Up until Google Stadia's announcement, this all seemed like fantasy or wishful thinking, but it feels like all the pieces are falling into place. Microsoft is launching their own cloud gaming solution, and so will Amazon eventually. Nvidia has their version, and others will follow. Add to that a cloud version of the Adobe suite, and many might start to question the need for an expensive big box, especially at the prices that hardware companies are charging. If the 2080 Ti costs, say, $300, I don't think this would be much of a discussion, but the way things are going, it seems to me like RISC-V is on track to really disrupt the PC market in the next few years, including the consumer desktop segment. Now, this is not necessarily what I want, it's what I think could happen. I love building PCs, I love playing with AMD chips and Intel chips and Nvidia GPUs, but whichever way you look at it, the current situation is not sustainable for the PC market. PC sales are going down, while thin devices are becoming more popular. Apple just announced a $350 iPad with enough processing power to run the applications that most people need. Even laptops are starting to make less sense, let alone desktops. In the second half of next year, the new consoles will come out, and again, these will be cheap machines that offer good 4K 60 gaming experiences for the price of a mid-range discrete GPU alone. There's a huge opportunity here for some company to completely disrupt the desktop market with thin devices with a Netflix-like subscription model to fit your needs. And RISC-V, for the reasons I stated, looks likely to be the innovation that enables this revolution. This video was made possible by my awesome patrons. Did you know that my patrons get access to exclusive video sessions on computer architecture? Did you know that they get to chat with me and other like-minded enthusiasts every day on Discord? That could be you. So consider joining my Patreon and help my channel continue to exist. If you can't contribute financially at this point, then please share this video on social media, as that really helps. Thanks for watching, and until the next one.